Hello everyone, how are you doing guys? In this video, I will show you how to find or how to calculate something related to system of two particles. One of the things that you will be asked about it, find the resultant force exerted on the pulley by the string. Something like this. If we have object like this, two objects, right, hanged on a pulley. Two objects, guys, will be influenced by tension force in this way. The pulley as well will be influenced by tension force in this way. In this case, similarly, the pulley will be influenced by tension force in this way. In this case, the pulley also will be influenced by tension force in this way. If you remember, always the tension acts on the object along the string pointing away from the object, right? Pointing away. So the tension will exert force on the pulley, or the string will exert force on the pulley. How we will calculate this force? Simply, I will show you something that can be used. It's a reduced formula. Can be used to find the resultant force on a pulley. This is the formula. The resultant force on the pulley equals root the value of the tension, times root 2 times 1 plus cosine theta, where T is the tension and theta, it's the angle between the two tensions. Let me show you the possible cases. The first case, this is the first case. Okay. The first case, we have two objects hanged on the pulley like this. Here, guys, the two tensions are in the same direction. If you see them here, two tensions are in the same direction. So theta between them is 0, right? This is the first tension. This is T and this is T. Sorry for this. So here I have two tensions on the pulley. The first tension acts downward and the second tension acts downward. So theta between them is 0. So I have to substitute here as 0. Okay. So if I substitute 0 here, this becomes T root 2 plus cosine 0 is 1, right? 1 plus, 2 times 2 times 1 plus cosine 0. So T equals root to 4. So this is 2T. So the resultant force is 2T, okay? Now the direction, it's obvious that the resultant force here is downward. The second case, as what we mentioned before, this is the tension, and this is what? Tension. The angle between these two tensions is 90. So theta here is 90. So I can find, I have to substitute 90 where? In the force of the pulley, on the pulley, tension, the value that of the tension that you have found before, 1 plus cosine 90. Okay, so this would be root 2 times T. Now, guys, pay attention to the direction because you will be asked sometimes to find the direction on the pulley, the resultant force on the pulley. Please do the following. Please draw. Here there is a tension in this direction. And here there is a tension in this direction. Okay? The resultant force should be between them like this. Please show this for the examiner. Now, and also please show this angle for the examiner. always this angle alpha, it's theta over 2. And in this case, it's 45. Look to the third case. Here, as what we mentioned, there will be a tension force on the pulley in this direction and tension force on the pulley where in this direction. Always the tension, acts along the string pointing away from the object. So this is theta that I should substitute where this formula, t root 2 plus 2 times 1 plus cosine theta. Now theta depends. Here theta depends on this inclined plane. Okay. Now if I want to find the direction, I have to draw also as the following. Please do what will I do now when you want to show the direction. This is the first tension, and this is the second tension. These arrows must be the same because the two tensions are the same. The resultant force should be between them. This is F net. Also show this for the examiner. This is alpha. Alpha always theta over 2. Similarly, guys, if I have a wedge like this is theta. Okay. Now, this is the first tension, the pulley, and this is the second tension, the pulley. So I have the two tensions like this. The resultant force will be between them. Similarly, if we have pulley on an object like this, right? So the two tensions on the pulley will be in this way. This is the first tension, the pulley, and there will be a tension on the pulley in this direction. So what should we do? We have to find this theta, right? You'll be given this angle, right? And you can find this theta by adding 90 or something like this by the complement of this angle. Again, how we will find the direction, guys, in order to find the direction, I have to draw. This is first tension on the pulley. This is the second tension on the pulley. Please try as much as you can to make the two arrows equal. Now the resultant force should be between them, exactly midpoint, because the two tensions are the same. This is alpha. Alpha should be equal always theta over 2. So in order to find the direction, you have to draw and you have to show the examiner the value of alpha. Okay? This is how to find the resultant force exerted on the pulley by the string. Let me show you some questions like this. In this question, a fixed rough plane is inclined at 30 degrees to the horizontal. A smooth pulley P is fixed at the top of the plane. Two particles A and B of mass 2 kilograms and 4 kilograms respectively are attached to the ends of the light inextensible string, which passes over a pulley P. The part of the string from A to B is parallel to the line of greatest slope of the plane, and B hangs below P as shown in figure 2. The coefficient of friction between A and the plane is 1 root 3. Initially, A is held at rest. The particles are released from rest with the string taut. A moves up the plane. Find the tension in the string immediately after the particles are released. Here, guys, in these type of questions, as what I told you before, I should deal with each object separately, right? Each object what? Separately. Now, here, let me show you this again. This type of questions, as what we mentioned before, we have to draw axis parallel to the direction of motion and axis perpendicular to the direction of motion like this. Then I have to show the forces or draw the forces on the object. Here I have tension. Always the tension acts along the string pointing away from the object. There is a weight always perpendicular to the ground. This is 2G. Here there will be a normal perpendicular to the surface. And since it's moving up, as what it's mentioned here, there is a friction that acts in the opposite direction of motion. This is friction. Now for the second object B, I have only tension. And I have what? 4G. Okay. If the motion of A is up the plane, the motion of B is down. Okay. Now I have to deal with each object separately. Sorry. Before doing this, sorry for this. I draw axes to show you which force must be resolved. Remember this, please. Which forces must be resolved? Any force does not lie on the axis should be resolved. This is the main objective drawing the axis. Tension lies on the axis, R lies on the axis, friction lies on the axis, but the weight or this force, which is the weight, does not lie on the axis, so I have to resolve it. Without deep thinking, if you remember, this angle is 30. If you would like to know why, let's consider this triangle. Look to this triangle. This is 90. This is what? 60. If you consider this, right? If this angle is 60, so this angle is 30 because it's a complement of 60. So always, guys, always, if the angle of inclination is 30, consider it with the y-axis. You remember, this is y-axis, and this is what? X-axis. Now, since the angle is given with x-axis here, this becomes 2g cosine 30, and here 2g sine 30. Okay? If the angle is given with y-axis, so the y-axis takes cosine and the x-axis takes what? Sine, if I can say that. Okay? I resolved what? The weight. Now, after that, I have to apply what? Newton's first law. I will consider each particle separately. For A, F net equals ma. Now, I showed also here the direction of motion, right? The direction of motion. Now, in this equation, I have two parts. Part for the forces, or part for mass and acceleration. The part that is used for the forces, which is F net, right, will depend on the direction of motion. The force that is in the same direction of motion, it's positive. The force or the forces that are in the opposite direction of motion should be considered negative. Here, for A, the motion is up, tension in the same direction of motion, so it's positive. Friction and 2g sine 30 should be considered negative. So look to this part, T minus friction minus 2g sine 30 equals what? The mass, which is 2, times A, which is unknown. Now, since it's moving, guys, since it's moving, remember this. Here, the friction equals F max, right? The maximum possible value for the friction. I will consider the maximum possible value of the friction as a friction if the object is moving. So in order to find the friction equals mu times r. Now, what should I find? I should find r. R, guys, lies along y-axis. Based on the axes that I draw them, r lies where? On the y-axis. Look, you go back here. This is r. R lies on the y-axis. So what should I do? If r equals mu r, we have to find r, which is along the y-axis. So f net along this axis, which is the y-axis, right, equals 0. Why f net along this axis is 0, which is the y? Because there is no motion along this axis. The motion only along the plane, right? There is no motion along the perpendicular axis. What does this mean? Guys, opposite forces are equal. If there is no motion, if the acceleration is 0, um, opposite forces are equal. Here, what do we have opposite forces? R, right? Opposite to what? To 2g cosine 30. Okay? So, just 1 second. So R equals 2g cosine 30 because they are perpendicular. If you do the calculation, you will get that R is 17. Now substitute mu times R, you will get that the value of R. So substitute here again. If R is root 3, which is a mu, times R, which is 2g cosine 30, minus 2g sine 30 equals 2 times A. 2 times A. Now I have two unknowns, tension and acceleration. What should I do? I have to do the same thing, but for particle B. Why? Because if you remember, as long as the string is taut between the two particles, the string is taut between the two particles, um, they will have the same acceleration, same tension, same speed, same velocity, same everything. They will be, or they must be, does as a one object, the whole system, right? So they have the same tension and acceleration. Now the motion for B is down the plane. Okay, so I have to consider B for B. If net down the plane equals MA. Sorry for this. Okay, so F net down the plane, right, equals MA. Again, we have two parts, part for forces, part for mass and acceleration. The part for forces, it's 4g minus t. Why 4g minus t? Because here, 4g in the same direction of motion, tension in the opposite direction of motion, right? If you compare the forces with the direction of motion. So it becomes 4g minus t equals 4a. Now I have two equations, guys. Right? Equation of motion for A. This is the first equation. And which is called equation of motion for A and equation of motion of B. I will solve them simultaneously. Right? Like this. Look. The first equation is t minus root 3 times 17. The calculation of 2g sine 30 results 9.8 equals 2a. 4g minus t equals 4a. If you add them, if you just add them, tensions will be cancelled out. So I have 4g minus 1 root 3 7 times 17 minus 9.8 equals 2a plus 4a equals 6a. So eventually I found a, which is 1 over 3g. Since I found a, I can find the tension by substitute the value of a in any value or any of the equations above a or b. So 4g minus t equals 4 root 3 1/3 g. So the tension is 26.1. Okay. This is a very common idea about a system of two particles. You might be asked to do the following, guys. You might be asked to calculate the resultant force on the pulley by the string. right? Resultant force on the pulley by the string. Now the pulley is being affected by two tensions. Tension in this way, okay, and tension in this way. Now I have to find the angle between the two tensions. I have to find this angle, by the way. This is 30. This is 90, right? So this angle should be 60. Now I will substitute in this formula, the reduced formula that I told you about it. F net on the pulley equals T root 2 times 1 plus cosine theta. Tension is found 26.1 root 2 times 1 plus cosine 60. If you substitute this, you will get 45.2. This is the resultant force on the pulley. This is the magnitude for the resultant force. Now I have to show also the examiner sometimes the direction. In order to show the direction, I have to draw the following. This is the first tension, and this is the second tension on the pulley. The resultant force should be between them. This is F net. I have to show this for the examiner. Now this angle, which is called alpha, it's theta over 260. So I have to show the examiner that this angle is 30. Okay? Okay. Let me show you another question. Here, system of two particles. Let me show you how to add forces, draw force body diagram first, then we will solve the question.